Good evening. Yeah, what are we going to talk about? We're going to talk about this, structure and interpretation of test cases, which sounds like an incredibly dull title, because it is a dull title, but it's intended to be a reference. It's a reference to this book here, Structure and Interpretation of Computer Programs. Now, it was published in the 1970s, based on Scheme, a whole lot of computer science stuff in it. Very little of which I'm going to refer to. In fact, almost none. But I am going to refer to some computer science stuff, because I think we often miss some of the deeper insights that connect testing to things we might already have learnt in other places. And that's what I want to do today and this evening, is to connect a few ideas. I want to show you some ideas, but I also want to connect things to other points you may have already encountered. Okay, and I like to believe that there are very few things that you actually need to know in software development, but we keep repackaging them. Okay, but the other reason, principally the reason I wanted to refer to this title, one is I like the idea of structure and interpretation. Things have structure, we assume meaning. And often our test cases end up being really flat, one-dimensional, and you end up with classes that have hundreds of test methods, and you wonder, why is it this is so difficult to work with? Because anything with 100 methods is difficult to work with. It doesn't matter that it's a test case. But there's a deeper idea here, one of communication. So, from structure and interpretation of computer programs, programs must be written for people to read, and only incidentally for machines to execute. And this is really interesting, because often the way that people have got a lot better at testing. I've been in software development long enough to know that this is an exciting new thing, well, relatively new. The fact that people actually bother writing tests. People used to talk about doing tests. We've moved on. Okay, there's actually tests out there happening frequently. You know that people are doing tests because they're always complaining about them. That's how you know it's real. But there's something else here, which is even more true. Still, when many people approach it, they do it because they feel they have to, that they are feeding the build process. I'm writing the test for the machine to execute. That's part of our build. That's how. And it's like, nah, we're missing something. There's something deeper here. And I want to get to that deeper thing. Oh, just as an incidental note, there are two reasons I'm showing this. One will appear on the next slide, and one appears right now. 97 things for every programmer should know. I edited this about 10 years ago. Currently, Trisha G and I are co-editing 97 things every Java programmer should know. It should be out in the new year. No, it will be out in the new year, because it won't be out this year, I can tell you that for free. Yeah? So yeah, Trisha and I are working on that one. But I'm referring to it here, not because of that, but because of something that, and where are you hiding, Gerard? There we go, there's that. Yeah, so Gerard Mazaros, write tests for people. Now this seems like a really obvious thing, but it deserves a title. That's who you're writing it for. You're not writing it for the build process. The build process is another client, it's another stakeholder. That's great, but the actual act of writing, as opposed to the act of executing. The execution is for the build process. The writing is for somebody else. Who is that somebody else? Who should you be writing the test for? Now, this is the really interesting thing. Gerard points this out. It's for the person trying to understand your code. Now, that's a really subtle thing, because there's something he's not saying there. The thing he's not saying, you are writing the test for the people who want to understand your tests. No, you are writing the test for the people who understand the code that is being tested. Good tests act as documentation for the code they are testing. Perhaps not the only documentation, but they serve a role. And philosophically, that changes what you're doing. It's no longer I'm writing a method to poke another method, to prod it and see if it comes back green or see if it comes back red. It's a fundamentally different philosophy. Now, I'm not going to focus on TDD today, but I'm going to focus on a property that I think is kind of interesting. It's one that Alistair Coburn pointed out a few years ago. He said, many people say TDD when they really mean I have good unit tests. And that's kind of interesting, because he's actually saying something different there. You know, my experience is that I deal with a lot of teams. I work for myself, I visit companies, I do consultancy, I do training, I do workshops, I do all kinds of things, and somewhere in there, there's normally something about testing and developer practices. And often I encounter people saying, oh, well, we're doing TDD. And I look at it and they're not doing TDD, but they are doing unit tests. They're probably doing more unit tests than they used to, but they don't have a name for we're doing more than we used to. This is the separation. TDD is a way of doing something. Good unit tests, guts, which I think is lovely. I have guts. Guts are a thing, not a way of doing a thing. They're not a how, they're a what. So whatever it is that you're doing, if you're doing TDD or you're doing old style test after, doesn't matter. Whatever it is that you check in, you want guts, or rather the next person who reads it wants guts. That's what they want. In fact, I've written a little bit more on this just the other day. I haven't put a link to it yet, but it's going to be part of 97 Things Every Java Programmer Should Know. It's one of my contributions. It's Program with Guts, and it's very much focused on a very small aspect of a few things we're going to discuss here. But I'm going to start off with something that I wrote years ago. I used to write for the Register on the developer stuff, and technical articles rather than news articles. And the first thing is, can anybody agree on what a unit test is? And it turns out the answer is no. Unit tests are older than I am, the concept. They date right back into the 60s. People were talking about them then, and I still can't find anybody saying a unit test is this. There's no single point of origin. There's no single unique definition. So if we can't have a unique definition, perhaps we can have a useful definition, a definition that helps us. Okay, here's one. This is close to the way that people tend to have started to think about it or agreed to think about it over the last decade or so. A unit test is a test of behavior whose success or failure is wholly determined by the correctness of the test and the correctness of the unit under test. Now, it might take a moment to unpack this, but I want you to think about this. It means that when it comes back with a fail, it means that it's either you've got the test wrong or the code that is being tested is wrong. If it comes back with a pass, it does not mean that it works. It increases the probability that it works. Yeah? But the one thing we want is that fail should mean something's wrong. Green means it might be right. Red should mean it's absolutely wrong. What this definition, it seems very simple, but what it actually tells you is that you can have no external dependencies in a unit test. Because if you have an external dependency, you don't control that dependency. You don't control the file system. You don't control the network. You don't control scheduling and thread sequencing. You don't control the ordering of asynchronous operations. You might influence all of these, but you control none of them. And therefore, they might fail and cause correct code to look wrong. So this is a very subtle distinction. It's about isolation. I don't care what you're isolating. You can think in terms of classes. You can think in terms of functions. It doesn't really matter. But if that piece of code that I've got my Eye of Mordor focused on fails, then something should be wrong. It's as simple as that. That's all you want from a good unit test. That and the why. Why did it fail? What is it trying to do? But let's look at this idea. What that does, that simple definition, what it does is it divides your code base into 3. And 2 out of 3 is good. One of them is not good. Let's look at them. This is the part of your code that is unit testable. Therefore, this is the stuff that is unit testable. Yes. Now, I've been very optimistic here, perhaps too optimistic, I don't know. This graph, I used to have this drawn differently. It used to have a little circle inside it. But I think, we should aim for something. So this is the code of yours that is unit testable. This bit on the outside, this is necessarily not unit testable. It's not unit testable and should not be unit testable because it's the bit of the code that actually has to deal with the mess that is the outside world. Okay? Sometimes people say, oh yeah, but you can mock that. Yeah, but you're not testing that it works. You're testing that your idea of a file system works. That's not the same as a real file system. There's a subtle distinction. There is a bit of your code that actually has to interact with something that you do not control and can fail for reasons that are beyond your control. And that's fine. You can still test it. It just means it might have performance issues. It might have unexpected failure modes. But you can still write tests for it. And that's absolutely fine. It's necessarily not unit testable. In an ideal system, this would be it. But clearly, we don't live in an ideal world. Yeah, there's a whole lot of code that it should be unit testable, but it isn't. You talk to somebody and they say, oh yeah, I should be able to unit test that. And then you look and they say, well, hang on, why does this depend on this, which depend on this, which goes off to a database that has a conversation with my best friend? And then, what's all this? And this tells you about the coupling, the dependencies that shouldn't be there. Logically speaking, that shouldn't happen. So this is why I define this as a useful definition, because it gives you feedback. It tells you something about your architecture, which is quite useful. Now, this idea of good unit tests, it's an idea that's been kicking around. I realized Alistair Coburn said that in 2008, but I discovered an earlier article by a guy called Todd Golding that I'd read straight past. It was a very useful article at the time. He said the programming made unit testing more about applying and exercising frameworks. Many people I meet, they're focused on, I'm using JUnit. Therefore, knowing JUnit is the key to unit testing. Knowing the framework that I'm using is the key to good tests. And therefore, I already know how to program, and I know how to learn new frameworks. I'm done. That's not quite it. I'd essentially reduced my concept of unit testing to the basic mechanism of exercising a unit testing framework to verify the behavior of my classes. My mindset had me thinking too narrowly about what it meant to write good unit tests. So, what's one of the other things we want from unit tests? Unit tests, I've talked about the failure and the success, the fact that they can tell us something about our design. We often talk about good coverage. Good unit tests give us good coverage. The problem I find is that most people have a very weak notion of coverage. So Martin Fowler had this to say: from time to time I hear people asking what value of test coverage, also called code coverage. In fact, strictly speaking, Martin manages to miss the right term here, or the more precise term. Most people end up, they don't really talk about coverage, they talk about statement coverage. And I sometimes insist that people say statement coverage because statement coverage is more precise. It means that you're not looking at branch coverage. You're not looking at the value space. You've just touched statements, that's it. 100% statement coverage means you've touched every statement once. Well done. You have not touched anywhere near a good fraction of the combinations of execution. Okay? It's just a reminder, because 100% sounds very complete, but it isn't. It's barely a start, if you look at it from that point of view. But actually, that's not the bit I'm interested in. Good unit tests can cover much less than 100% statement coverage and still be considered good. The motivation here is really to understand what you're interested in is the classes of behavior. If you've tested all of the happy day scenarios but none of the rainy day scenarios, guess what? Tomorrow in production, it's going to rain. Okay? Failure is just as legitimate. That's the idea. There's the idea you can actually test it. It's the edge cases, it's the weird stuff. But that's also a matter of communication. Does the caller of that code know that there's weird stuff, there's edge cases? We probably want to tell them. How will we do that? We're going to find we already have the answer. But nonetheless, code coverage as a statistic can sometimes be useful. They should aim for or stating their code coverage levels of prime. Now, this idea of aiming for it is an interesting one. Such statements miss the point. Brian Marrick has this lovely observation, and this is kind of where I sit on this one. I expect a high level of coverage, high level of statement coverage. Sometimes managers require one. There's a subtle difference. A target is not an observation. When people make things a target, then it changes the nature of the game. And you end up with accidental workarounds. People don't even know they're doing it. Oh, you know what, I can keep the coverage a little bit higher if I just don't catch anything here. Oh, yeah, that was easy. That's good. Yeah, it turns out that's a really good way to increase the coverage. There's a whole load of things that you can not do to increase the coverage. And that's the problem. You end up leaving stuff out. So, then we hit the text. So I'm going to pick on one of my favorite examples. It's one of my favorite examples, has been for years. There's a very good reason it's one of my favorite examples, because it turns out that it is simple and captures a surprising depth of behavior. When is a year a leap year? When does a year have a 29th of February? According to the Gregorian calendar. I'm going to make a few simplifying assumptions. I'm going to presume that the Gregorian calendar has always existed. Okay? If you would like to deal with the locale specific aspects, it turns out that the rollout of the Gregorian calendar is one of the slowest rollouts in history. It started in the 1580s, it finished in the 1920s. If you would like to do that, that's your homework. It's very locale specific. And if you can do Sweden correctly, email me. Okay? Sweden tried to adopt the Gregorian calendar twice. They didn't quite get it the first time. They decided that they would gradually adopt it. As in, they would be wrong with the Julian calendar. I think they did this in 1700. What they did is they added a day. So they kind of, the idea was we'll drift from one calendar to the other, one day at a time. Turns out that was not very practical. Unfortunately, when Sweden changed sides of the road in the 1960s, they decided not to migrate from the left-hand side to the right-hand side using the same philosophy. Okay? So we're going to keep things simple. However, even in that, it turns out that we have a number of challenges. So let's start off. How are we going to write a test? Hey, I've just discovered JUnit. This is fantastic. Great, I'm going to write a test. You know what? You could be more specific. I'm going to test the is-leap year method. Yeah, but you haven't really said much. You've just said, you know, I can see the method, and I can say, oh, you mean I should write test is-leap year is correct? No, that's not at all what I mean. Because why would you test that it's wrong? There's a lot of noise. There's a number of noise words that we find, and pretty much every test base has one of these words. You sometimes find somebody has a test is leap year, test is leap year is okay. Test is leap year is successful. Test is leap year, it works. There's lots of variations of this, but I'm going to say you probably want none of them. Now, just notice something. Let's just see if I can just shift. Does that work? No? Yeah. So this is not where we want to go. This is also not where we want to go. Because it turns out we've just merged all of the interesting cases into one. We're testing all the different cases, leap years and non-leap years. Again, this is a very popular practice. I've actually visited a couple of teams where, I've even seen we realized we needed to split our test cases up. They were becoming too big. Oh, good. Yeah, so we've got test 1, test 2, test 3. Actually, that's probably worse than leaving it all in one place. Yeah. Now we're getting somewhere. Now we're beginning to acknowledge a little more of the domain. Not only are there leap years, but there are non-leap years. Now, I kind of probably could have guessed that from the name, but this is a start. Now, what we find is that the problem here, assert true is leap year 2016, assert true is leap year 2000. It turns out these are both leap years, but it turns out they are leap years for different reasons. They are not leap years for the same reason. We'll get to what that reason is, but it turns out these do not belong together. So perhaps we want to split things out. Yeah, now, here we've got a bit of a problem. Test 2016 is a leap year, test 2000 is a leap year, test 2018 is not a leap year, test 1900 is not a leap year. The problem is, there's nothing. What we've done is we've put this data specifics in the name. I've turned data examples into specifications. Because there's no difference. I could equally well replace these. First of all, I'm going to get rid of the test because I want to emphasize the point. That's the first thing. The name test. Did you know you're in a test? Did you know you're in a test base? Yeah, we've already said that. There's probably the word test is probably in the file. It's probably all over the place. You probably already know this. Don't repeat yourself. So I'm just going to drop that to there. I'm also going to put in underscores, which some Java developers will get very upset about. That's fine, get over it. We'll come back to it later. But what is interesting is if I just drop this out, let's just focus on the names. What happens if I change this to 2020 and I change that to 2400 and 2019 and 2100? It turns out that all of these are also valid. Now, if you did not know what a leap year was, all I've given you is 4 different numbers. I gave you 4 numbers before. I've now given you 4 different numbers. Have you learnt how to determine for yourself what a leap year is. Okay, there we go. This is what we want. This is a bit closer to what we want. It's not quite right yet. We'll get there. Years divisible by 4 are leap years. Years divisible by 400 are leap years. Divisible by 400 is actually a different rule, which suggests years not divisible by 4 are not leap years, and years divisible by 100 are not leap years. 1900 is divisible by 4, but it is divisible by 100. It's an exception to the rule. The reason people struggle to remember the leap year rule is because it's a rule which has an exception, and there is an exception to the exception. For most people, that's just too much. Okay? It's too complex. It turns out there are 4 parts to the rule. There are 4 kinds of year. And 2 of them come out as leap years, and 2 of them come out as non-leap years. Now, there's a little bit of reshuffling we have to do here. I'm going to resequence this so that we deal with the largest category first. Test ordering is an interesting thing. For something like a pure function, it's not always obvious what the ordering is. If you're dealing with testing an object has a life cycle. It tells a story. Typically, I would start with, what happens with a new one? Tell me what happens when you create this thing. But there's no thing created here. It's a pure function. So what I tend to do is I look for other aspects of the domain. In this particular case, it turns out that I'm going to deal with the size of the data set or the size of the sample set. The largest category is years that are not divisible by 4. None of them are leap years. This year is not a leap year. Last year was not a leap year. The year before that was not a leap year. So roughly 3 out of 4 years are not leap years. Let's start with the biggest case. Then let's move in. Next year, that's a leap year. And it's a leap year because it's typically divisible by 4 and none of the other stuff, the hundreds or anything like that, applies. So we'll do that. And then 100. And then the smallest category is what year 2000 was. It's divisible by 400. But there is also a problem here. There is a problem here. And what is the problem? The problem is that years divisible by 100 are also divisible by 4. And if you look closely at the names, these names contradict one another. This one is quite confidently saying years divisible by 100 are not leap years. The one above it says, I disagree, because years divisible by 4 are leap years. These cannot simultaneously be true, which gives us a new insight. Years divisible by 4, but not by 100. In other words, this is the precise rule. Now, this actually applies in other cases. You want your test names to be mutually exclusive. I find in many test suites, people will have things like test foo on a bad day. It has a completely different result. Well, hang on, does that mean what's the other one? Oh, test foo on a good day. So be precise. What you've done is you've learned. Well, in fact, this is a good way of looking at it. You are learning about the domain. Here, the domain is very, very small. It is the domain of leap years, or years with respect to leap years. But we've now learned how to talk about it. It turns out there's not divisible by 4, there's divisible by 4 but not by 100, there's by 100 but not by 400, then there's by 400. When you write your tests, you're not simply just checking something works. You're explaining how you understand it. And that sometimes means resequencing, renaming. There's an important point here. The names that you first write down are probably not the names you want to check in. They're kind of like, this is the first idea I had. Think of it as like writing on a whiteboard. You come back, yep, I've got a better name for this. I now understand this. This one should go first. This one's not the right name. It's kind of right, but not quite right. You're iterating towards an understanding. So there's your naming. That's not bad. But clearly I need to resize the font. Now, there are other schemes. This one is, I'll come back to this one in a moment. This is what can be referred to as the propositional style because it's based on the idea that your names are like a logical proposition. They represent something, and that thing can be true or it can be false. Okay? It is cold outside. Turns out that's a true statement. Yeah? Years not divisible by 4 are not leap years. I'm making a statement about the domain, and it has a truth value. Now, there are other ways that people describe these. Roy Osheroff has this approach, which I see sometimes. People like to focus on the method, the input, the result. Okay, if this helps, absolutely go for it. So the method in question is leap year. The input is that it's a year not divisible by 4. The result is that it returns false. Okay, so we've got a partitioning of how we organize the name. There's lots of other schemes here. I care less about some of the specifics as to the fact that notice what you've done. You've explained how something works. All of these contain the same information. They just emphasize different things. Now, my personal preference is on this idea of the logical name. In fact, this is one of the books I learned logic from, which sadly dates me because people just don't produce books that look like this anymore. You know, people are, this is before Comic Sans, there was this, okay? However, there's a point here. Propositions are vehicles for stating how things are or might be. Only indicative sentences, which it makes sense to think of as being true or as being false, are capable of expressing propositions. This has a rather interesting property. Here's the test names. Here is an implementation. The tests pass. What is interesting here is that everything in green is a property of your code that we have, to some level, increased our confidence in. It's like, yeah, okay. This is a statement of the capabilities. Right, I'm going to replace the Gregorian rule with the Julian rule, the Julian calendar. What's great about this is that one fails. The hundreds rule fails. Now, why is that great? It's great because it tells you what you don't have. Basically, what is wrong with the code? Well, this is not true. Apparently, years divisible by 100 but not by 400 are leap years. It is exactly the opposite of the name. If I call this test is leap year, that wouldn't help. Test is leap year divisible by 100, that also wouldn't help. This one tells me what is the property that is missing. It is the opposite of what it is that is stated. So red is helpful. Red is just another way of saying not. So this is more specific. That's why I like the propositional style. Now, this also captures something else. Nat Price and Steve Freeman ran this session at XP Day in London in 2007, if I recall correctly. Brilliant title. Are your tests really driving your development? What they really focused on was actually what we would call good unit tests. For tests to drive development, they must do more than just test that code performs its required functionality. They must clearly express that required functionality to the reader. That is, they must be clear specifications of the required functionality. This idea of tests as specifications is something that has become increasingly popular. Initially with BDD, but more broadly, and Nat and Steve have been doing this quite a long time. They are the inventors of JMock, which is the granddaddy of all mocking frameworks. So I'm going to structure this. This is a structure that is JUnit 4. I'm going to do something else with it here. I'm going to switch this to JUnit 5 because it explicitly supports the concept of nesting. And then I'm going to drop away all the noise so that we can have a clear idea of how to think about this. And this is the key. Remember those really long names. The problem that we find with tests is yeah, it's fine to have a long name because you're never going to call it. It's called automatically. But that doesn't mean it's automatically readable. Sometimes Java programmers forget this. I noticed this with some of other things with Java. Oh yeah, that's fine. My class name is 100 characters long, but you know, I've got an IDE that's really wide. You know, I've got a big screen, and no, I'm still a human being. I still struggle with, I don't want to get neck ache reading your class names or your method names, okay? However, what we've got here is a recognition. If I've got a class and it's got tests in, and there are 100 test methods, as I said at the beginning, that's going to be as unreadable as anything else that has 100 methods in. Just because it's test doesn't make it more readable. But what you'll notice is that these are not arbitrarily long. Your tests have repeating parts. They have duplicates. Duplicate words, duplicate phrases. Sometimes those phrases are to do with the setup. Sometimes they're to do with the outcome. Take advantage of that. We know that one of the things you can learn from duplication is abstraction. So that's what we've got here. What we've got, this is a specification of what a leap year is. Now, I'm not going to call this leap year tests. I'm going to call it leap year spec. A year is a leap year if it is divisible by 4 but not by 100. A year is a leap year if it is divisible by 400. This is, I could almost lay it out on a PowerPoint slide. In fact, this is a PowerPoint slide. Good grief. How good is this? You can just copy and paste from the names. And that's what you're getting. So there is this idea, very simple idea. If it is by, we have grouped the common outcome. A year is a leap year. A year is not a leap year. And we've captured the rules. So we've grouped things. This is now a specification. Now, there's something else I can do, and I'm going to go back to this question of the underscores. It turns out that camel case does not really scale well beyond about 30 characters. People's reading speed drops off. There are alphabetic systems where people are more familiar with dealing with this, but the Roman alphabet is not one of those systems. All languages, all spelling systems that use the Roman alphabet have basically evolved to use some form of spacing. That's how the spelling systems work and so on. It turns out that capital letters are not enough to boost the significance beyond about 30 characters. You just end up with letter soup. Okay? You need spacing. Underscore is a good space. But even better, as a result of me popularizing this, JUnit 5 now has this. Awesome. At display name generation, display name generator dot replace underscores dot class. What does that do? Well, it kind of gives you an output that looks exactly, like this. It will replace underscores with spaces. So you actually get that as your test output, which is quite nice. Yeah? You've got other ways of customizing that, and you can also put your own generators in. There's a lot of capability here. Okay, so enough of that. Let's focus on the content of this. Year is not a leap year. If it is not divisible by 4, assert false. Okay, so I want to focus on the values for a moment. Is it important that this is 2018? Is it important that that's 1900? I'm going to say no, it isn't. I could equally well put the numbers 42 and 100 in. But there's a reason I don't. These are not wrong. It turns out choosing your test data is helpful because these have a property. These look like years. In fact, I've done this with people. If you write the year of if somebody shows you an integer that happens to be the year of your birth, you cannot not associate it with the year of your birth. Okay? You look at that, year of my birth. There's nothing you can do to stop that, except a complete mind wipe. Okay? It turns out that we have, as human beings, we do not simply think of this as a set of integers. We have associations. If I put 1984 up, 1984, it's a book, it's a film, it's a year, it's a whatever. I don't just simply think of it as an integer. But if I put 42 or 100 up, yeah, that looks like years. No, it doesn't. It looks like two integers. In fact, 42 reminds me of Hitchhiker's Guide to the Galaxy. That's the strongest association. Yeah, sure, 42 is technically a year, but that's not how I think about it. So what you're trying to do is you want to help the reader. You want them to think in your domain. So that means if you're dealing with a system where you're taking people's addresses and you're taking people's names, then might I suggest that foo and bar are terrible names for your children. Nobody who has any kindness in their heart will name their children like that. These are not sensible names. Choose things that look like names. Choose addresses that look like addresses. Okay? So there is this idea, what you want is for people to go, that's a year, that's a year, that's a name, oh yeah, you've got the accent there. This is the kind of thing. I want to see these things that make it clear to the reader, yes, we have understood your domain, we're using your terms, but it also allows them to think, oh, you've missed a case. Or what about this? Or what if I use a space here? And so on. Now, we might want to improve our coverage. In a simple case like this, I can simply duplicate assertions and just have multiple assertions in the same place. 2018, 2017, 42, 1. I don't mind putting in these other weird ones once you've got the, choose something representative, then choose something that's more of an edge case. But data-driven tests are a little more helpful. In other words, we recognize that a test effectively has three parts, or three aspects to it. It has a name, which may be structured in terms of nested scopes. A name that tells you, here's what I'm about. This is the thing that I am about. It then has a body of code. In this case, it's just one line, one expression. This is the code that is being tested. And then there is data. And here are examples of the data that works with this. Sometimes these are embedded inside the test case, but they're actually orthogonal. So you've got like three axes here. There is the name, which is the purpose or the thing being tested. There is the code. This is what it looks like. And let me show you some data. And you can generalize this. This is the basis of property-based testing if you take it far enough. So I can do this. I can do this for the whole class, and I can use multiple examples. It allows me to improve my data coverage without disrupting the structure of my test. It allows me to take tests that have a single data value, and once I'm comfortable with that, generalize them quite easily without changing the structure of the test, without introducing for loops and arrays or anything like that. So it's a much more declarative approach. So tests being declarative is quite a useful idea. There's a lot of power here. So we can see, the examples as representative. Now, something else. It turns out that I've not read Anna Karenina. Very few people have. But the opening sentence is quite well known in its various translations. And in English, all happy families are alike. Each unhappy family is unhappy in its own way. What this tells you is that the happy day scenario is normally fairly simple. But how do we deal with failure? Tell me about failure. I don't just want to say, and this thing doesn't work. Be more specific. What I'm going to do here is I'm going to add in a constraint. I'm going to say that our code is only going to apply to common era dates, so the year 1 onwards. Okay? So what I'm going to do here is I'm going to say a year is not supported. We're not supporting if it is 0. So I'll throw an illegal argument exception. If you've not used JUnit 5 before, that's your job tomorrow. Okay? Because testing failure in JUnit 4 is a lot more painful. If you're still on JUnit 3, then it's massively painful and you won't have been doing it because it's so painful. But JUnit 5 makes it really easy. And if that, it's got lambdas. I mean, what more do I need to do? Okay? So lambdas, what I can do is I can say, here is this expression, this one fails. That is a positive outcome. I can also separate out negatives. -1, -4, -100, -400. None of these are supported either. Now, what is interesting is that I could merge these two. A year is not supported. I could clearly merge these. If it is 0, if it is negative, I could make these not positive. Why don't I have a single test case? Well, it turns out sometimes you write test cases to draw people's attention to something. What you're doing, if you think about it as writing a document, what you're doing is you're underlining something. You're putting it in bold. You're putting it in its own section. You're saying, I want you to see this. I have paid attention. I actually once I ran a workshop and the whole class disrupted into, well, is there a year 0 or isn't there? It's a fascinating philosophical discussion. You want the alcoholic version of the beer to have it. Actually, it's not that interesting unless you're really into date handling. Is there a year 0? And of course, the answer is, it depends. It depends on what calendar system you're using. It depends on when the calendar system was adopted. If you are, and it turns out for many people, they say, oh, no. The way it formally goes in history books is it's defined as 3 AD, 2 AD, 1 AD, 1 BC. Okay, it doesn't have a 0. Except if you are using the ISO 8601 calendar, which it turns out everybody is, because that's the calendar of the internet. If you're using an online calendar, guess what? You have a year 0. You just haven't gone back that far. Yeah? ISO 8601 is a calendar that has a year 0. The astronomical calendar has a year 0, because astronomers aren't going to sit around going like, if less than, then minus. No. They just say, imagine it's a number line that goes all the way back, okay, to the beginning of time. In fact, beyond. But it includes a 0. It makes the numbers, it makes the arithmetic easier. So instead of having these fascinating discussions and filling your tests with, guess what I've just learned about date handling, and are we using ISO 8601? We're simply going to say we're not supporting it. And I want you to understand, I've thought about it, here it is. Oh, and here's the negatives. We're making it a distinct case. Sometimes you add a test case not for coverage, but for emphasis. If your colleagues keep coming up and saying, what about this case? Oh, you say it's one of the data items in this other test. If they keep asking you that, pull it out, make it explicit, make it visible. Okay, so it also suggests by symmetry, here's an interesting one. Sometimes make it clear what you're implying. I've run this as a workshop exercise. Every now and then I find somebody puts a maximum up a year. Sometimes it's 2,400. The most common one is 10,000. And I said, well, where did that requirement come from? Well, I thought I'd put, no. This is one of those developer-invented requirements we keep running across every now and then. It's just like, no, let's make it clear. We mean that this goes all the way up to the top. It turns out, this is one that was added to JUnit 5 as a result of my insistence, assert does not throw is really useful. because it allows you to say, guess what, this isn't going to throw. Now that would be what an ordinary test case would do. If I just put in, is leap year, but it wouldn't have an assertion. It would make it look like I'd forgotten the assertion. I want to tell you very specifically and explicitly, this does not throw. That's the point. When you read it, you say, that's supposed to work. So that is there for completeness. It's just a confirmation. If you were thinking about this, yes, that is the case. If you hadn't thought about it, guess what? It's still the case. We've made it explicit, no surprises. Okay, now that's as far as I can take it with a single function. So now we're going to look at the most over-specified example in the history of computer science with the possible exception of the sorting algorithm, the stack. And this is a stack of books, objects as it happened. It turns out my mother's, well, she's a retired psychotherapist. Turns out psychotherapy, they're obsessed with objects, just like us. Fantastic. So, let's talk about stack. What are the things I can do with a stack? Here's 5 things. I can create one, I can push, I can pop, I can get the depth, and I can find the top. Okay, this is a nice, easy, minimal stack. How are we going to characterize it? I don't want to talk about its internal implementation. I want to talk about its behaviors. I want to talk about its signatures. What are we expecting? Barbara Liskov. Anybody come across the Liskov substitution principle? Okay, yeah, it's the L in solid. That's her. Barbara Liskov has been basically contributing to computer science since the early 1970s, distributed systems development, language design, data abstraction, methodologies. She's a brilliant woman, won the Turing Award in 2008, if I recall correctly. This is from her work on abstract data types in the early to mid-70s. She's the person who basically came up with this. An abstract data type defines a class of abstract objects which is completely characterized by the operations available on those objects. And so we can characterize it. This is fantastic. It allows me to use an upside down A and a back to front E. Yeah, this is just gratuitous. Now the point here is I've just given you a bunch of signatures, but I haven't really described what we're expecting of it, and I need to translate this to Java. I'll also come back to the fact that some of these are partial. What do we do with operations that are not always defined with respect to their input? We'll come back to that. So what that tells me is that this is generic. I can construct it, I can push, I can pop, I can depth, I can get the top. I guess sometimes people want to put gets everywhere. I'm not a big fan of that. It seems like a noise word. And honestly, if you're going to do it, you might as well just go the whole distance. You know, put do in front of everything else. You know, not helpful. So I'm just going to keep it really simple, really straightforward. Now, instinct, and particularly with certain tools, if you say, you know what, I want you to auto-generate me some test stubs. They do stuff like this, which is utterly pointless. It is the worst code generation in history. I'm going to test the constructor, I'm going to test it. This is exactly the same problem we had before with test is leap year. Test push, test pop, test, no. First of all, let's get rid of the test word. Now it looks really stupid. Okay? So we've got this one-to-one alignment. But I want to point out, test constructor is an interesting one because if this is my class, in most cases, in most code that I find, the default constructor doesn't actually do anything useful. Sometimes you just move its bodies to field initializers, which means you end up with no constructor. That's kind of interesting. You don't need the constructor. So wait a minute. Does that mean I don't need the test? Because the compiler generates the default constructor now. So then people will say, oh, take that out. Now what is interesting is that we've confused the implementation with the idea of what would you like to be able to do with the class. That is what Barbara Liskov is talking about. Don't worry about who's implementing it or how. What should you be able to do with it? I can still construct it in exactly the same way. Whether or not there is an explicit constructor, not important. The fact that it can be constructed is really important. So, there we go. Sometimes people will then say, I see what you mean, Kevlin. Can be constructed, can be pushed, can be popped, has depth, has a top. Well, this is also a bit of a test naming smell, because what you've just done is exactly what we had before, but you've just used the word can and has instead, and it makes it sound better, but actually it's exactly the same. But also there's something here that's not entirely true. Can you pop an empty stack? No. Can you get the top element of an empty stack? No. Oh, right, I see what you mean. Can sometimes be popped. Can sometimes has a top. Now, yeah, there's a problem here. I'll just leave you with Chris Aldwood's. His feed is great. So here's an interesting idea. A specification. Something that John Jagger pointed out to me a while ago. The first few letters of specification are specific. This is not specific. This is vague. It's a bit like saying, yeah, you know what, sometimes this does what you expect, and hey, maybe some days it doesn't, you know, how are you feeling? That's not helpful. I need to know more. So there is an interesting framework that popped up, courtesy of behavior-driven development, given when then. So this comes from Dan North, and there's a simple way of phrasing things and organizing it, and that will allow us to kind of think about our names more specifically. It may also, if we take it too literally, it may take us down the wrong road. Let's explore this. Given when then. This is a kind of useful phrasing. Given an empty stack. This is clear. We never said that before. We just said can be constructed, or can be pushed, or when an item is pushed, then it should not be empty. Okay, there's a couple of issues with this. One is, I'm not a big fan of the should word. If that helps you, go for it. It sounds, I've got a 17-year-old son, and it kind of sounds like, yeah, what I just did there. You know, like, huh? Yeah, should, There's lots of extra noise words there. You know, then if it's okay with you, I think that perhaps it should probably not be empty, don't you think? It's that kind of negotiated, yeah. So, Strunk and White wrote a really interesting book, one of the standard books on writing English style, the elements of style. And it turns out that they were actually talking about test cases, but they carefully disguised it as an English style guide. Make definite assertions. None of this kind of like, yeah, you know, whatever, should. Well, maybe it should, but maybe it shouldn't. I mean, who knows? Should is not a strong word, you know. What time, you know, my wife asked me yesterday, what time are you leaving the house to go to the airport? Oh, I should be gone by 8. But everybody in my house knows that means, Dad, you will still be here at 8 o'clock. You will still be here. You'll probably leave about 8:30 in the morning. Yeah. Should is kind of like, yeah, I kind of ought to, but you know what. Yeah. Right. Avoid tame, colourless, hesitating, non-committal language. When a sentence is made stronger, it usually becomes shorter. Get rid of the noise words. Brevity is a byproduct of vigour. So now, sometimes people go the other way. It's like, it must not be empty. It's like, whoa, easy there. Okay, I get the message. Honestly, just keep it simple. It is not empty. It's a simple logical statement. Now, we've got another problem here. This is not wrong. None of the previous ones were wrong either. We were just focusing on the question of style and precision and directness of message. But it turns out that we're being vague. It is not empty. What was the depth was an int. How many values are there for an int? It turns out that there's about 4 billion of them. Only one of them constitutes emptiness. That's 0. There are 4 billion other values that would fit this specification. This is called a vague test or a weak test or an underfitting test. It turns out there are lots of wrong answers that could easily pass this. Yeah? We actually have a very precise answer. It has a depth of 1. 2 is wrong, 3 is wrong, 4 is wrong, 5, keep on going. Yeah? It's not just that it's not empty, it's not just that it's not 0, it's actually something. You put one thing in, there is one thing. Oh, and the one everybody forgets? The top item is the item that was pushed. This is what I tend to call a lot of objects, a lot of classes, a lot of systems, a lot of constructs have this what we could call conservation rule. You put one thing in, there is now one thing, and it is the thing that you put in. It's not mysteriously transformed into something else. Yeah, it's a really simple idea, simple conservation of value. Okay. So, this is good. What are we going to do for a test name? Got it. Kevlin mentioned underscores. Yeah, even so. Sometimes, now, so I get this question a lot. I get asked by people, should I use the given when then in my test name? Just as with should, my guideline is if it helps you, absolutely go for it. But sometimes what you find is that you reach a point where it's done its work. It's already changed your mindset. And it's now just noise. Yeah? There's this idea that the practices that you adopt are not always going to be the same all the way through your career or the career of a code base. When a team is starting out with a new idea, sometimes they need to be a little slower. They need to be more explicit to bed it down. Just as when you learn anything else, you do things that after a few years you drop doing. That was my beginner stage. Now I'm a senior engineer, and so is everybody else on the project, or everybody else has been doing this practice. It's so common in our project that that's just the way we do it. But it doesn't help by adding more words. So perhaps we just go to a simple proposition. An empty stack acquires depth by retaining a pushed item as its top. Back to Strunk and White, and one of my favorite pieces of advice in that book, omit needless words. One of the reasons it's my favorite piece of advice is that it's self-referential. There are no needless words in this 3-word phrase. Okay? So, we can cut words, but only if you're comfortable. Okay, here's a stack spec. An empty stack acquires depth by retaining a pushed item as its top. Stack string of stack, new stack, stack push jug, assert equals 1 stack depth, assert equals jug stack top. Now, occasionally I get this question, and it's characterized here in this particular blog. This is referring to Roy Osheroff, warns against his multiple asserts in unit tests. Occasionally this rule gets thrown back at me. People say, oh, you shouldn't have more than one assertion in a test. I generally ask why. People are not able to give me a good answer. Normally they said because a friend told me, or because I read it in a blog, or because you just shouldn't. Actually, it's a little more complex. It's not about syntactic assertions. It's not about how many assert statements I have. It's how many concepts I am exploring. My guideline, so Roy responded to the blog, my guideline is usually that you test one logical concept per test. That's what you're interested in. You can have multiple asserts on the same object. They will usually be the same concept being tested. Okay? Sometimes there's this careful balance. Sometimes you accidentally split one idea into 2 ideas by putting it into 2 different test cases. It looks like the asserts are unrelated, whereas actually they should be related. It's not just that there's one thing. It is the thing that I put in. That's really important. So we might bind it like that. But also be careful when you count assertions. It turns out that your instincts might be slightly wrong. Assert equals 1. I can say there are 2 assert statements, but how many things are being tested? I can actually expand this. Assert not null. It turns out that the string assertion also checks for null. Notice that this has exactly the same behavior as this. And this has exactly the same behavior as the previous slide. Now, there are reasons we don't do this. We recognize aggregate concepts. And sometimes we have the data types that map them. We don't break down the string one character at a time, you know. In fact, there's one concept I've missed as well. There's another thing. Also, JUnit checks for you that this does not throw. In other words, those 2 assertions are actually a shorthand for 6 assertions. So be careful when you talk about the numbers. It's dependent a little bit on the framework, the style, and so on. But in all cases, we're testing one concept. Clearly, I'm not encouraging you to write this. I'm just demonstrating a point. This passes and fails in all of the exact same circumstances the other code does. But also be careful with that advice, because I find that it's immediately contradicted when people use mocking frameworks. If you're using a mocking framework, any test with more than one expectation is a test with more than one assertion. And just remember, an expectation is just another way to spell assertion. An expectation is an assertion about a future. In fact, some frameworks even use the word expect as an alternative to assert. So just because it's spelt differently doesn't mean it's not an assert. So if you have multiple expectations, guess what? You have multiple assertions. It's as simple as that. So that's fine, as long as you're testing one idea. I can even group all of these together, cunningly enough. Assert all. I can make it one assert here. Yeah. So there's lots of ways of gaming the system. I'm not encouraging you to game that, but I can label all of this together and call it a law of conservation. Anyway, that's all good fun. It's just to get you to think, you know what? Is it one idea? Or am I just simply counting statements? If I'm counting statements, I might be heading down the wrong road. Okay, so here's what my stack looks like. A new stack is empty. An empty stack throws when queried for its top item. In fact, we can apply that. An empty stack throws when popped. An empty stack acquires depth by retaining a pushed item as its top. A non-empty stack becomes deeper by retaining a pushed item as its top. A non-empty stack on popping reveals tops in reverse order of pushing. This is fantastic. We've actually got a full life story of a stack. Okay, let's look at something else here. There's something going on here which is very subtly indicated, and it was subtly indicated using spacing, but I'm now going to make it more explicit. If we go back to that Jared Mazaros article, he makes it very clear. For each usage scenario of the test, describe the context, the starting point, or the preconditions that must be satisfied. Illustrate how the software is invoked. Describe the expected results or post-conditions to be verified. This is sometimes known as arrange, act, assert, the 3 A's. It's also known as given, when, then. It turns out there is no difference between these two ideas. All that happens with given, when, then is that this is in fact the same idea. It's just a different spelling. In fact, this idea is quite old. Jason Gorman from the London software craftsmanship community. Fun fact, given, when, then is what we call a Hoare triple, named for Tony Hoare. Originally, it's kind of typically written like this, PQR. Originally 1969. This is the paper, Axiomatic Basis for Computer Programming, where in his original formulation, he identifies it like this. And what he says, if the assertion P is true before initiation of a program Q, then the assertion R will be true on its completion. Let me translate that for another way. Given P, when Q, then R. Preconditions, actions, postconditions. It's exactly the same idea. All that's happened is we've gone and reinvented it. It was reinvented with use cases in the 1990s, behavior-driven development in the 2000s, but it all started back in 1969. It's one idea, okay? But this talk of preconditions and postconditions sometimes has people going like, wait a minute, couldn't we just skip all this testing stuff and use an idea that was pushed in the 1980s, programming by contract, where we formalize pre and post conditions as a contract on how a class should behave? That sounds like a really good idea. In fact, the idea of a contract actually goes back to the early 1980s. Butler Lampson wrote about this. An interface is a contract to deliver a certain amount of service. Here he's referring to interface broadly, just as a class interface or a module interface or something. It's not the language construct. He was a little bit optimistic. He said clients of the interface depend on the contract, which is usually documented in the interface specification. Yeah, most developers leave everything out after the comma. What would that look like for Stack? If we had this feature in Java, and there have been extensions that allow you to do this, but it turns out there are some limitations. This is not as effective as testing. Postcondition of the constructor, the depth is 0. Yeah, that seems reasonable. Postcondition of push. Well, if it was pre-depth before, then the postcondition is it's pre-depth plus 1, and the top is the new top. That seems reasonable. I like that. Now it starts getting a little bit weird, because we then say, well, if the depth is greater than 0, then your resulting depth will be 1 smaller than it was. But what's your top element? We don't know. It turns out the weakness of the pre- and post-condition model in this approach, as opposed to the way we do it in tests, is there is no sense of history. It only works for things that are truly stateless. We really see the problem here. Depth. Postcondition, the result of depth is greater than or equal to 0. That's it. It's 1 of 2 billion values. I'm sorry I can't help you. Are you feeling lucky? It's a 50-50 chance. That's a really weak specification. If somebody said this is a contract for behavior, what happens when I call depth? Oh, you get a number that's not negative. Could you be a little more precise? No. And top is disastrous. Precondition. The depth must be greater than 0. It must not be empty. What's the postcondition? Honestly, I couldn't tell you. I can't tell you what you're expecting to be returned. It has no history sensitivity. It turns out that the pre and post condition idea is one that everybody falls in love with, but eventually when they try it, they discover it doesn't work in practice. But there's another one with the same book cover that does. I'm going to borrow an idea from Tony Hoare again. This is not exactly how he has it in the book, but he likes to think of a process. Let's imagine that a stack is a process. Right, don't worry about the concurrency. Well, let's model it as if it were. And what I'm going to do is I'm going to say, what kind of language does it have? What's its alphabet? Yeah, it's basically, what are the things you can do with a stack? You can have a new one, a push, a pop, a depth, a top. Huh. And now what we're going to do is we're going to say, and what are all the ways that we can communicate or manipulate a stack? So here is a trace. This is what is referred to as a trace. And what it is all the legal interactions you could ever have with a stack. Let me clarify here. This is a sequence that says you can create a new stack and then forget about it and let it be garbage collected. This one is you can create a new stack and then call depth on it and then let it be garbage collected. Here's another one. You create it, you can push it, and then you can pop. Notice that there are no sequences here that are new followed by pop or new followed by top because they are not legal. So this is the set of all legal traces. How big is that set? You might notice there's a small detail at the bottom of the screen. For those of you that can't see it, it says ... This is an infinite set. If you have any new junior programmers on the team, give them this. It'll keep them busy. Actually, we already know how to do this. This is a grammar. You can generate grammars from state machines. We don't need an infinite set. This is how to think about a stack. A new stack becomes empty. You can push, it becomes non-empty. You can perform depth, top, push, and pop in all of these cases, and it remains there unless the depth is equal to 1, in which case it becomes empty again, in which case you can only call depth. What about top? What about pop? You can't call it here, it's not specified. Ah, that's kind of interesting. In other words, the state machine is actually a simple way of looking at our tests. A new stack is empty. An empty stack throws when queried for its top item. That's what we did with top. An empty stack throws when popped. An empty stack acquires depth by retaining a pushed item as its top. A non-empty stack becomes deeper by retaining a pushed item as its top. A non-empty stack on popping reveals tops in reverse order of pushing. This is the history sensitivity. I can say that in a test because I have the state encapsulated within the test. This is kind of neat. It means that there is a relationship between other ways of looking at the stack and how we drive our tests. Okay, is there anything I want to focus on here? What did I want to do? Oh, yes. Another thought. An empty stack acquires depth by... In all of these cases, you will initialize a stack. I can equally well pull out a before each, basically a setup method, and I've tried to make the naming consistent. So from this point of view, you see an empty stack is created. An empty stack acquires depth by retaining a pushed item as its top. Many people will just call this setup, but I'm saying actually you can name it consistently. But there's something else going on here. What I've just done is my grouping, how I group them together, was based on a very simple idea. I grouped everything according to the givens. Given a particular state, I'm going to group all the things with the same given. Given it's empty, given it's non-empty. So I'm using the given as my structuring element. Now, if you're thinking along these lines, you might say, well, hang on, can I group things according to the when? Well, yes, you can. You can group things according to the common operation. I could easily take all of those tests and restructure it and say, when I push onto an empty stack, when I push onto a non-empty stack, these behaviors of this, I can organize it differently. I can even group things according to common then, common outcome. In fact, without you realizing, that was exactly what we did with the leap year. Then it is a leap year. So given when then is not simply a way of just organizing the inside of a test case or a test name. It actually tells you how you can factor out and create a hierarchy of nesting for your test cases. And it's entirely up to you as to what you think is valuable. I think the reader should be shown common state or common setup. That's a very common one. I think the reader should be shown common action. Sometimes you want to emphasize common action. So I think a really simple example for the common action is that idea of finding. If you find something, there are normally two results. I try to find a thing that is there, and I try to find a thing that is not there. Yeah, so every find method has at least two cases. Perhaps you want to put them together. When finding a thing, when it's there, when it's not there. Yeah? So what you're doing is you're helping the reader. You're saying, I want to group these together because you'll think about it together. Okay, so we've kind of seen all of this. So here's the thing as well. The other aspect is you are showing the reader how the code is executed. You are giving them an example of usage. This is really important. People love examples of usage. Okay. Oh, let me go back to if they could just say it, let me go back to the test, see how he called it there. I was like, oh, but she did it like this. Oh, that's legal as well. Fantastic. Now I know more about how to use this class. But it also shows us, interestingly, any problems. And this is one of the key things here. I'm just going to focus on these two statements here. Stack.depth, stack.top. Very often for this, and in production code, I see things like this. Well, maybe not like this. That's public data, but I still see code with public data. Sometimes people say, no, it's fine. I've made it private. Yeah, you know, that's only kind of private. There's not a lot there is a bit of difference between this and this. But what we've just done is we've just returned an underlying collection. Things I've learned over the years is that collections in interfaces are often smells. Hey, I've given you my private collection of stuff. Do what you want with it. Or maybe there's a comment saying, please don't do what you want with it. But who reads comments? Okay? So the point here is you can immediately see that. Your test is your first point of contact. And this has a particular name. This is a test smell. It has a couple of names. But my favorite name for this is train wreck. Because it's like a pile of, you've probably seen them. And it's okay when you're dealing with a fluent interface because you're not actually diving into an object model. Something dot something dot something dot something. But where that something dot something dot something is not just a language exercise, but you're actually digging into the depth. You are actually violating some basic encapsulation things. You are telling people, yes, there is a collection here. Yes, you can do what you want with it. Yes, it will be a list. I will never change my mind and turn it into a map. I'm now committed. My internal implementation is now committed to this. This is a fundamental violation, even if we get rid of the get. So I'm going to go back to this. The idea is optimize your interface for how people actually use it. Don't force them to go and dig out the internals of an object. Okay? Actually, genuinely, no public access. Okay, this is the abstract data type lesson that Barbara Liskov wanted us to learn. Now, what I'm going to do is I'm going to say, we're going to move on to a different data type. Here is some beer. This is me as a younger man last week. That's what that much beer does to you. No, this is me with my co-author Frank Bushman and Mitchie Henning. This is about 15, 16 years ago in Denmark at a conference. These days I have slightly less beer. But in all of these cases, what I want to get you thinking of is this is a queue. What can you do with a queue? You just go, oh, it's the same as a stack. No, it isn't. I'm British. Queuing is it's a cultural pastime, okay? You can have a new queue. It has a length. The metaphor is subtly different. Although Java naming conventions make everything size, actually stacks have depth, queues have length. Queues do not have depth unless something's gone terribly wrong, okay? Something that's also important, capacity. There's a limit to queues, okay? They have a natural, we'll talk about that in a moment. And I'm going to choose slightly different. I've always found push and pop for queues is a bit weird. I'm going to use NQ and DQ. So how do we understand queues? A queue is basically a relationship between a producer and a consumer. That's what a queue is. That's it in all cases. It doesn't matter if this is a queue between processes, a queue between one piece of work and another piece of work within the same process, whether it's asynchronous, synchronous, it doesn't matter. This is great, because now you can impress your colleagues. It turns out that a queue is a space-time decoupling. Okay? Okay, so now you can say, tomorrow you can go in and say, do you know, between this component and this component, I think we need a space-time decoupling. Whoa. Just a nice little bit of general relativity thrown in there. It makes it sound much, much cooler than it is. And queues have different characteristics. They have a size. If they have a size, some n, it means it's buffered, it's bounded, it's asynchronous. If n is infinity, then it's unbounded. Don't do this. Queues will fill up. When you say, oh, that'll never happen, it will. And it turns out that computers are finite. Computer scientists hate infinities. Don't let your system crash. You should always have a limit. Always specify a limit. Now, there's some interesting cases when we say n equals 1. What is the use of n? What is the use of a queue with only one item? Well, it has a special name. We call it a future. And sometimes we call the other side a promise. Remember I said at the beginning there's only a couple of ideas in the whole of computer science? They just get reinvented, recycled, yeah? Once you've got a queue, you have just got every single synchronization abstraction in the history of code, okay? You've just got everything. You can turn things from, oh yeah, that's an interesting one. What happens when n equals 0? You've got a synchronous rendezvous. You've just reinvented a pure mutex. You've just reinvented the Go channel. There's loads of stuff, yeah? So there's only one idea. However, I'm just going to keep this one simple. I'm going to say we're going to keep it greater than 0, so 1 or more, and less than infinity. Okay, this is the interface. This is what it looks like. I'm also going to change my style slightly. The style here is that it is bounded. I'm not going to use exceptions. I'm going to choose a slightly different model. I'm going to enqueue, and an enqueue can be yes or no. Yes, that was enqueued. No, it wasn't. It's no longer a failure mode. It's just I'm sorry, we couldn't do that right now, but come back later. It's a Boolean. Similarly, you can always dequeue, and you will either be slightly disappointed or you will get a value. Yeah, it's an optional. I'm sorry, there's nothing here right now, but feel free to come back later. Yeah, it's perfectly standard way of looking at it. Now, you might think, I know exactly what Kevlin's going to do. He's going to do this. Yeah, you're really close. What I'm actually going to do is this. Queues are more interesting. They have nested states. In other words, there are two ways of being non-empty. There's not being full, and we behave differently when we are full. When we're full, we no longer accept new in queues. When we're not full, we accept all in queues. There's a subtle difference. We have a relationship around the value of capacity. Now, I'm not going to dive into all the tests. I'm just going to give you it all at one go. Okay, I'll take out the dashes. But what you can see here is exactly how that state relationship corresponded to it. Now, I'm not saying you need to draw state diagrams. That's absolutely not what I'm saying. What I'm saying is that if you wanted, perhaps you were drawing on the whiteboard and your colleague said, hang on, what happens in this case? Oh, well, wait a minute, this happens. Ah, right, we should test that. Or alternatively, you're testing and somebody says, hang on, show me what happens over time. You go the other way. What I'm saying is these ideas are interchangeable. One informs the other. It can help you see something you could not otherwise see before. But that nesting comes all the way through. A new queue is empty. A new queue preserves positive band. Yep. An empty queue dequeues an empty value. An empty queue remains empty when null is enqueued. An empty queue becomes non-empty when non-null value. That's great. Then we get the nesting. A non-empty queue that is not full becomes longer when non-null value is enqueued. A non-empty queue that is full ignores further enqueued values. So what we've got here is a very explicit relationship that you can see both verbally, but also you can relate it to another visualization. In this particular case, it's a state model. The queue itself is not that interesting. It's not thread safe, just in case you're worried. Yeah. Shit, how did he make that thread safe? Cheap answer, that's your homework. I didn't make it thread safe. So I'm going to end the talk by reflecting a bit on some things that have changed since the 1970s, the 1960s, and whenever. In the 1970s, Nicholas Wirth, the inventor of the Pascal programming language, wrote a book called Algorithms plus Data Structures equals Programs. I believe this must have really pissed off his publishers, because a book title with a plus and an equal sign. These days we have all kinds of stuff. People have book titles with emoji in them. But back in the 1970s, it's like, I'm sorry, this is a kind of professional publication. We do proper computer science publication. You can't just use symbols in your titles. He did. But I'm going to take this as a useful way of thinking. It shows the way that perhaps our thinking has become deeper. Algorithms plus data structures equals programs. What I'm going to do is I'm going to say, no, structure plus interpretation equals programs. That's where we are now. Thank you very much.
So what do you think about assertion libraries like Hamcrest or Asserts, and is there a reason why you didn't mention them?
Right. What do I think about assertion libraries, Hamcrest being one of the most popular ones? Yeah, Asserts. Yeah, fine. I don't have a problem with them. I didn't mention them because I wanted to just keep it fairly simple, go straight, rather than saying, I prefer this one to that one, immediately starting an argument. You know, is that everything that I could express within the context here was sufficiently expressed. But what you're doing there with those is they give you, the way I describe it is, they give you a richer assertion vocabulary. They don't change what you can say, but they do change how you can say it. And you may find that is useful. So in other words, I think it's like improving the quality of an image. Everything is still there, but you see it a little better perhaps. Yeah. So in those cases, yeah, sometimes they allow you to say something a little more precisely. And that's fine. Yeah, I don't have a problem with that. As to which one is better and whether you should go and write your own, I leave that as a matter for discussion, debate, argument, violence, whatever. I don't know. Yeah. Yes?
Do you know any GitHub repository with such tests for like more complex domains?
Do I know any GitHub repositories with such tests for more complex domains? No, not off the top of my head. No. I mean, I know people have shown me stuff, but that's private code basis.
The follow-up question would be, this seems to be quite complex to make such simple statements, because then you have to have very deep understanding of the domain, which is most likely not the case.
Right. So yes, you were going to need good understanding of the domain to get this. For me, I think that there is a complexity here, but the complexity is always there. Your choice is not whether you have it, it's the choice is when and where you have it. So for me, it goes back to a comment that I made earlier on, and let me revisit that and expand it a little bit, is this idea of what you're really doing is you are learning to talk about the domain. Now, the point there is that when we start, perhaps we have a very simple idea. I have a very naive idea of stacks, okay? But as I start describing it, I start realizing, and somebody says, well, what about this? Oh, that's okay. Well, that queue example, what happens when I enqueue a null? Well, that's not allowed. How do you know that? Oh, well, let me make that clear. Rather than tell somebody, oh, well, you're not allowed null because the code says you're not, because I throw a null pointer exception there. Now you're describing now you're relying on the implementation, whereas actually probably that's a public property. Guess what? Null is not allowed. So what I've just done there is I've taken something that was already there and I've publicized it. Another way of looking at these kinds of tests is that it's stuff that was already said, but now I'm capturing it to avoid saying it again. That's the interesting thing. One of the things I've discovered, and so I'm going to relate a wonderful experience, learning experience for all parties concerned, many years ago, where one guy spent 20 minutes arguing with me about a unit test case that would take 5 minutes to write for their production code. Because he said, this is not really going to be worth my time, it's so trivial, and it just states something that I already know. Now, there are two things that came out of this. One is the question of time. You've just spent 20 minutes describing why writing a 5-minute test would be wasteful. I think you're down 15 minutes on where you started, okay? That's the first thing. The second thing was there was an awful lot of I. Sometimes it's not for you. Sometimes you're clarifying your thoughts, but sometimes, honestly, it's for somebody else. What is obvious to you, it turns out, stating everything sometimes reveals assumptions that you cannot see. And somebody else will come along and they will say, oh, I see there's an assumption. You go, oh, yeah. You're dismissing it because you always knew that. But for them, it's a discovery. Yeah? But the opposite may happen. They will see an assumption, oh, but you haven't tested for this, that means. Haven't I? Oh, you're right, there's a gap. So that's what you're doing. What you're doing is you're turning the conversation to something that normally lives in the air into something that's been checked in. So I'm not going to say, you need to come out. So clearly, I've shown you everything worked first time on the slides. Actually, I showed you a little bit of progression in some of them. By the time we hit stack, there was only a little bit of progression. But in many cases, what you're doing is you're learning how to talk about it. These tests, it's the idea of come back, it's like, that thing I had, that's not the right name, or that thing I had as one test case is actually two, or those three cases are actually one concept. It's identical. I now realize there's a different class that should be there. So it's a reflection of this is what I think so far. So for me, that's the way of looking at it. It's conversations that would happen anyway, but now what I'm doing is making a note of them, just so we don't forget. You know? Does that make a bit more sense? So these are the things that will happen, but what we're doing is we're doing something different with that knowledge in each case. You had a question? Yes.
Some of the properties of the classes that we've designed here could be shown by the interfaces, basically making the improper impossible to actually build. For example, if you created an empty stack, you would say, or queue, you would say, this is an empty queue. That's a very specific version which does not have the method you wouldn't be able to call in a queue.
Indeed.
Split into between the tests and the language or the DSL create anyway. What do you think about that?
Yeah, you're requiring a different type system. That is the subject of a different talk. I actually do have that crazy idea implemented of the interface is dynamic. In other words, I don't make a method available. The code is in Python, and it's definitely don't do this at work.
I actually do this at work. The problem is with most of Java developers, because Scala developers get it right away, right? With most, and Kotlin developers are pretty good at it. With Java developers, they do not expect actually the interface to express the intent of the package.
We might be talking across purposes here. Scala is statically typed. You cannot have dynamic interfaces. Let's start with that. Right. So, how are you evolving the interface? Are you just returning a bunch of maybes or optionals?
Or you create several, just like with the collections, for example, in Java, which are completely wrong from the perspective of interfaces.
Mm-hmm, yes.
What you get with most of those interfaces and with most of the methods of the Java collections, you will get an exception from.
Yes, unsupported operation exception, yes.
So, because we are so used to it from the perspective of Java.
Right, let me just clarify. In Scala, you cannot write a piece of code that has a dynamic interface. So therefore, you're going to have to be casing on it. You're going to have to match on it. So basically what you've just done is reintroduce the switch statement by another name. Right, not a big fan of that. And I tend to regard that as a design smell. It has its place, but you force the user into doing certain things. So potentially it's useful sometimes, but I'm going to say that you're going to end up with some of the same complexity, it just now lives somewhere else. I think there's a more discussion to be had here, but when I replace a simple call with, and now I need to match on it, then I've made it not a simple call, which is kind of annoying. Yeah.
Sounds like not object-oriented programming.
Well, honestly, it sounds like procedural programming. And that, unfortunately, there's really good cases for pattern matching, absolutely brilliant cases. But the failure mode of pattern matching, we have a name for it. The failure mode of functional programming is called procedural programming. That's what it's called. And so what happens is the property that you're relying on is something else. What you're relying on is cool switch statements. You're not actually relying on anything more fundamental than that. That's a very, I'm saying that contentiously, there is a little more detail to it than that. But it is one of those cases, it becomes a lot more useful where you start relying on certain behaviors, like with optional. I can say, so in other words, give me this value if it's there, otherwise give me the default. That's useful. Therefore, what I've done is I've actually embraced the logic. It's now a simple expression rather than explicitly matching it out. I basically talked about the relationships of the data types. I think too many matches is just as smelly as too many ifs and too many switches. Sometimes polymorphism really is a simpler answer, which is why functional programming is really good, because it has polymorphism everywhere, higher order functions. So I tend to think if you're doing a lot of match-based code, there's something wrong. Yeah? That deserves more conversation. I can sense it in your look. Yeah. But sometimes the benefits that people are looking at are not the benefits that are actually there, they're side effects. There is another thing that allows you to do dynamic interfaces, and that's the bit that's not safe for work. So you're safe, you're good. But there is a different aspect there. I still have to write the same number of tests, though, for the Scala case as I did for the Java case. Because I have exactly the same number of cases, you can tell by counting them on the match. Yeah, it doesn't change the logical complexity of it. Damn, yeah. Yeah, it's food for thought. Right. Any other thoughts, reflections? Yes.
So basically you show another way of doing tests from me personally.
Yeah.
The underscore and stuff like that. Do you have any experience with rolling out that strategy in the teams?
Rolling the strategy out of the teams. Oh, okay, this is the hard question. Yes, I do have experience of this. Yes, it is not always, and guess what works for one team doesn't always work for another.
Can you repeat the question?
Sorry, yes, I did. I should have repeated that. Do I have experience of rolling any of these things out to teams? Yes, and the experience is sometimes massively successful, and sometimes people go, holy shit, why are we not doing that everywhere? Sometimes it's a kind of a process of what you do is rather than just showing that you're working with something. In fact, I did this with some SQL Server stuff. I'm not a SQL Server guy at all. I was working with a team, and they had a lot of tests. That was great, but I said, I'm really struggling with these tests. Can I suggest something if we name it like this? And they go, you can do that? Yeah, I think so. Let's try it. Holy crap, that works. Oh, what else can we do? And that, so I learned a lot about SQL Server, and they learned a lot about this testing style. In other cases, people have very strong habits, and it's just a case of it's very difficult to disrupt those. And I think it's great if people already have a set of testing habits, as opposed to dealing with people who don't have testing habits. That's a very different case. But sometimes you have these kind of questions. Sometimes people kind of agree with you, but they have different conventions, in which case it's one of those, okay, let's go with their convention, but we'll take one element of the structuring. What is the thing they just found helpful? They're naming it like this, but they find the nesting useful. Let's go with the nesting. Let's emphasize that, de-emphasize the other thing. Yeah, so it tends to be along those lines. Sometimes there are restrictions based on the tool, or based on tooling. Sometimes people say, oh, we can't do that because of our build tool, and I've seen it with other languages as well. We can't do that because this tool does not give us the visualization, or that's fine. You understand where your limits are. Yeah, you can't try everything, but you can try something. So, yeah, people take it up in different ways. But sometimes, as I said, different teams have different enthusiasms and sometimes different resistances. I get plenty of that on Twitter as well, because I say, holy crap, this is brilliant. How do I get my team to do it? Honestly, I've never met your team. I can give you a couple of suggestions, but they may respond differently because people are a lot more complex than code. Yeah, I know a lot of us retreated into software because we thought it might be easier, but you know what? No. Any final thoughts? Yes?
Do you have some experience with Spock that allows to express method names as text? So
Yeah, right. Do I have any method with Spock which allows method names? In fact, we can generalize on this. Sometimes you are dealing with constraints given by a language. Spock is native to Groovy and has a very different concept. Likewise, if one does this in F# versus something like C#, F# has a different sense of what can be a method name. It turns out the JVM does not have the same restrictions that Java has on method names. You can put what the hell you like in a method name, and it's okay. I mean, Scala freely allows you to put emoji and stuff in. That's not a recommendation. That's definitely But there is the idea that sometimes you can embed spaces in things, and that's legitimate as a name, and that's fine. So,
but I wonder whether it actually helps or it can be pulled too far. So if I can write a prose...
Right, yes, you can always take a good idea too far. Yeah, that is the nature of a good idea.
Do you have some experience whether it's such naming, such possibility to use white spaces? It helps much, or rather...
Generally, people, one of the things I've generally had positive experiences with it. There are some frameworks, particularly that allow that and make it a feature of the language, or in fact, I did one with the team. We developed one that was a Lambda-based one that basically allowed you to create, there was string plus Lambda, that was your test. So in other words, the tests were not named using Java identifiers. They were... Every test case was a pair. One is a string, so you can put punctuation in it, you can put anything you like in it, and the other is a lambda. What I have found is in these cases where people are allowed to have a bit more freedom, including spacing and punctuation, is they are more likely to have good names. I'm not saying they don't abuse it, But honestly, I've seen what people do with normal Java naming, and yeah, you know. But what I found, and I found this particularly helpful with some teams, particularly in the embedded space, particularly people coming from C who have a very fixed idea of what is allowed as a name, and they say, oh, I can only call this test foo, you know, and I need to get rid of all the vowels or something, you know. What they found is by getting away from the idea that this is an identifier, because we have habits related to identifiers. You know, you don't even know you have them, but when it comes, you're writing out a variable, you've already got a set of practices about how you name variables, how you name methods, and these flow naturally through your fingers. You don't even know you're doing it sometimes. So what we're trying to do sometimes with these tests is say, I want you to disrupt those habits. These look like methods, but they're not really methods, they're tests, and those have a different goal. I don't want you to name it like all the things you've ever named in your life. We need to name it differently. Sometimes actually having a different syntax, you're allowed to use spaces and describe it in free language, that can be very helpful. And I found that has been more beneficial. Yeah, in those cases, I've noticed a massive improvement. People who've gone from ultra short names have suddenly described what's going on. It's kind of like you've given them a certain freedom. Yeah? So yes, mostly positive would be my answer. There was one more question, and we'll call that one the last. Is this like the counting assertions? Are you doing that with me? I think you are. Yes, please go ahead.
Yeah, so first one, briefly, I assume you have some experience with Spock. So
only light. I'm no Spock expert, but okay, I like
besides the names, the naming,
the structure of the tests. Yeah.
How do you find it? Especially, I have some problems like I find people abusing the tables in where and all these features like that. So, what are your feelings? Is it like?
Yeah, I think generally it is, because I think that for me, being able to have, basically, for those who don't use Spock, you can have more table style things, which basically allows you to do the data-driven thing I showed you earlier, but more easily. Yeah, or more to the point, it's actually more transparent. I don't have to jump through a lot of syntax to achieve that idea of like, I want to run this test with 5 data items instead of 1. How much syntax do I need? And Spock says, not a lot, and that's fine. Of course, people will abuse stuff, and unless somebody has a really clever idea of how not to abuse language features, I don't have a quick answer to that. But generally, my feeling on this one is along the lines of it does more good than harm, and actually people, when they come from Spock, want that. They want that feature, which is why JUnit 4 was frustrating, and why up until relatively recently I'd always say to people, because I use a lot of different testing frameworks, and I'd say, honestly, the best testing framework out there that is widespread was NUnit 3. I'd say, yeah, you got the C# guys, they've had this for years. JUnit has been massively slow in catching up, and JUnit is almost where C# is when it comes, or almost where NUnit is. There's a few more refinements before it gets there. But the NUnit folks have been doing certain things and just like, oh wow, this is really easy. I find it's a pleasure there. It's not necessarily, so it's the simplest, most widespread framework, I would say, or the one that has most of the desirable properties. So yeah, of course you can abuse it. People are creative. People will always find a way of abusing a language feature.
Shitty code is technology.
Sometimes it's not shitty. Sometimes it's art. Okay, second question.
Yeah, second question. So I'm wondering, because these examples were in quite simple domains already. So I'm wondering, what are your feelings on using like expressive language in more complex domains where you have more complex cases and you abstract some of the complexity of your setup or into separate methods and stuff like that?
Right. So I think the interesting thing about the simple examples is the fact that they show you more than you would otherwise expect. I don't know anybody who's specified a stack quite as completely or has got a queue quite that. So this is an important point. That's what we're trying to do. But I also use it as a way of showing people this is the kind of level you want to reach with your more complex domain. If I've done this with a simple domain and I've shown you things that you weren't expecting and edge cases that you overlooked, then what about your real domain? Now, your real domain is where all the weird stuff happens. I've given you regular examples from computer science. If I start dealing with things like tax laws and stuff like that, and I need that to be as clear as possible. I need the next developer to come along and go, I understand what this is about, or I know the questions I need to ask the domain expert about because it's clear and it's here. So yes, you need to be this expressive. The bit you have to be careful with is that developer instinct, which is I could abstract some of this. Be careful how much or the way in which you abstract it. I did that very simple thing with the setup earlier on, where I try to make your setup as clear as your tests, because otherwise you're going to end up with magic. Okay, most extreme example was a test suite put together by one of my clients where they had abstracted everything. They had fallen so in love with given, when, then that was everything in their test. And when I say everything, I mean everything. Let us just imagine we have feature foo. And what they would do is they would have test foo, and they would have given foo setup, when foo action, then foo assertion. And I'm looking at it going like, what does this do? Oh, well, we extracted everything that it does. Yes, including the assertion, the code, and the setup. I have no idea what this code is doing. You might as well call it given one, when one, and then one. Because you've taken everything away that is useful to me as a reader. Oh, it's in another file. You don't have to worry about it. Yes, I do, because I have no idea what this code is doing, because all the code is now in 3 different places. I've got the given, they went a little bit crazy. I've got the given files, the when's files, and then the then files. It's just like, oh man, so there's that nature, you want to abstract something, but be careful how you do it. Well, you may actually end up erasing the very thing that is of value. So I'm not going to say you shouldn't do it, but I want you to do it cautiously and think, wait a minute, if I come to this, have I just taken away the thing that helps the reader, or have I reduced the noise and made it simple? There's 2 ways to go with abstraction. Yeah. Okay, right, on that note, I hope that's been useful.